So hi, this is Edmund and this is Shaquille, and we are going to
Yeah,
be
hi.
talking about, and we are going to be talking about the insertion, BTree insertion. So this is our tree at the moment, and the values we're going to add are 9, 100.5, 500, 499, and 401. So Shaquille's already done the presentation already this week, and I will just be going through a couple of the insertions, and Shaquille's just gonna make sure that I understand the code and how the algorithm works.
Yep.
Awesome. So I'll just jump in straight away. So we're going to be adding 9 to this tree. So first of all, the code here, what it does is it first of all checks to make sure that the root is not null. If we have a look here, it's not null. So that's good. If it was null, then we would basically add allocate memory for the root, and it would basically just add the value 9 there. So what happens now when we try to add the value 9, we're going to check to see if the root is full in this case. Just to note again, t is our degree, which is equal to 3. The maximum number of keys we're allowed at each node is 2 times t, which is 6 minus 1, which is 5. Just for convenience sakes, each of these nodes here, we're able to allocate 5 keys into their memory. Let me just get rid of these. And for this tree, the number of children we can have, so these are the children here. We've got 5 of them at the moment. The maximum number of children we can have is 2 times t, which is 6. So I'll just actually put 6 here and 5 here. So again, adding 9. In theory, what's going to happen is 9, we look at the root node, see that 9 is less than 100. So we move left. And then we have a look at this here and we check to see, is it a leaf node? Which it is. And then we're going to put 9 into the appropriate location. So 9 is less than 16, less than 15, less than 10. So what's going to happen is, oops, let me just delete this. What's going to happen is that we're going to move the values 10, 15, 16 along, and then we're going to insert 9 here. But in the actual code, so what happens in the actual code is that, first of all, we check to see if the root is full, which in our case is not. Feel free to jump in, Shaquille, if I make a mistake. So it's not full, so that's good. So we see that the number of keys is 4, which is not equal to the 5 here. So we skip all this and we go to the else statement, and here we're going to insert the key when it's not full.
Also, did you go, so everything you're doing right now is good, but then in the BTree insert method, so on the left of this code here, when you got down to root.insert non-full, so did you come to the else statement where it's a branch node and then go through the process of selecting the next node to traverse down to?
You mean this part here? Or
I can't see. What are you pointing to?
Oh, crap.
Oh.
Can you see my screen? Sorry.
Yeah, I can see your screen.
Did you mean this part here?
Yeah. Did you go through all that?
Not yet, no, because I thought we were at the leaf node, and that's why we were going through here.
Not quite. So basically what happens is, in the BTree insert method, when you get down there, you're calling insert non-full on the root node. So that's the very top node. So that isn't a leaf node because it has all those children. So what you were doing right now, that was all good, but basically what happened is you call, yeah, if you head over here, so you start out with your root node here, values 100 through 400, and then it's not in there, so you need to traverse down to that first child.
Oh, yeah,
Yeah,
gotcha. Because we're actually not at the leaf, so actually we
yeah.
go here.
So everything, yeah, everything you're doing was correct. You just missed that one step there.
So actually, I'll probably mention that as well. So Shaquille mentioned that once we run the root.insert non-full key bit of code, we actually check if we are at the leaf node. Currently, we're not. We're at the root node. So we skip all this and we check the else statement. And then I just quickly again, I is equal to 2 at this point. So here, I'll just change this to. So at this point, we're saying, okay, so I is equal to 2. Well, I is greater than 0, and the key is at 2, which is 300.
Yep.
And actually, let me write this right. Hi, this is Edmund. I'm actually making a big edit on the video because I looked at it and what I said and everything just didn't make sense. So I just felt for just this particular part of the video, it's better if I just redo it and then I'll return back to the video where Shaquille also spots something else that I mentioned. So we are at the bit where we are running this bit of code where we're going to check the node that we're on and see if it's leaf. So at this point, we go back to the top here now. I is actually equal to 3 because we're taking the number of keys, which is 4, 1, 2, 3, 4, because we are still at the root node, and we're minus 1. So 4 minus 1 is 3. The current value we are trying to add in, the current key we're trying to add in is 9. This bit of code here checks to see if we are at the leaf node. We are not. We are at the root node. So now we skip this part of the code, as well, and we go to the else statement. At this point, we're going to run this while loop, and whilst I is greater or equal to 0, and the value of the key at index I, which is going to be the this value, this value, this value, and this value of the root node. As long as that value is still greater than the key, then we know those aren't the indexes of the children that we're going to try and traverse through. We basically want to find out which child we need to traverse through the tree. So starting at where I is equal to 3. Is 3 greater than or equal to 0? Of course it is. And is the value at keys index 3, which is 400, is that greater than 9? It is, so that passes. So 400 is greater than 9. 3 is greater than 0 for I. This is the key of I. So that passes. So we decrement by 1 on I. So I is equal to 2 now. Go through the while loop again. And at this point, we are at index 2. Is 300 greater than 9? Actually, I should start on the other side. Actually, let me start again. So is 2 greater than or equal to 0? It is. So that passes. Is 300 greater than 9? We get 300 because we are looking at index 2, because I is equal to 2. It is, and that passes. So again, we decrement as well again here. So now I is equal to 1. We check again, is 1 greater or equal to 0? It is, so that passes. We are now looking at index 1. Is the value 200 greater than 9? It is, and that passes. So again, we decrement by 1 again. So I is equal to 0 now. So is 0 greater or equal to 0? It is. We are looking at index 0. Is the value 100 greater than 9? Which it is, and that passes. And we still decrement by 1. So at this point, I is equal to minus 1. I do make the mistake, I'm not spotting this, but Shaquille will spot this for me, and we will return to the video right now. Can I delete that? Yeah. Run the next bit of code at the bottom. Let me just get rid of this one. And basically, we're checking to see if the found child is full. Children in our case is 2 times t. No, children is I plus 1.
So in this case, since
children
we're
at what?
still on the root node, yeah,
Yeah.
children is referring to the array of children of the root node.
Right.
So,
right.
yeah. So then I plus 1. So what is I equal to right now?
0.
Yeah.
Yeah.
Are you sure?
Oh, it decrements by
go,
1 again, so it's minus 1.
yeah.
Gotcha. Yeah.
Yeah.
So that's
Because remember, we
-1.
want to select the first child.
Yeah. So it'll be like the child at index 0, the child of 0, which is like this one here.
Yeah, the child at index 0 is going to be that first node there.
Yeah.
10, 15, 16. Yeah.
Yeah.
9, 10, 15, 16.
Right. And yeah, and basically, it also checks the number of keys it's got to see if it's full. Right. All right.
Yeah.
Cool. So
because
if it
in
is,
that case, we're going to want to split it.
Yeah.
Yep.
Awesome. So at this moment, it's not. So because it's not, then decide which of the new children is going to have the new key. So key of 0 is less than the key.
Oh no, we're not gonna go there, because remember, the number of keys in the first child is only 3. You only had 10, 15, and 16. So that does not exceed the number of keys that a node can have. So you're just gonna go.
Yeah, I can see it. Straight to the bottom.
So then you're gonna go straight down to calling insert non-full on that child.
Yeah.
And then we end up where you previously were before I mentioned all of this.
Nice.
Yeah.
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 And then, should I just go? I might go through this again.
Yeah.
Hopefully the pen works better this time. So, okay, yeah. Thanks for that one.
Yeah.
All right. So now we've decided which, now we've moved down the tree. So we're going to check if the, and again, I is equal to 2 because of this. The current nodes. Oh, actually, I was equal to 3 before then. Yeah. Okay. So I might put a note on that one. So at this point, I is equal to 2 because it's the number of keys, which is 3, minus 1, so it's 2. We check if it is a leaf node, which it is. And I'm just going to put the indexes here. So what we're going to do is we're going to run this bit of code here. So here we're checking is I, which is 2 greater or equal to 0, which it is, and is the key at I, which is this one, is that greater than the key? The current key is 9. It is, so we're going to copy the key at I plus 1, which is 3, is equal to the key at 2. So we're actually going to copy this value of 16 to the index at 3. Decrement I by 1. So basically, we're looking at this one here now. Is 15 greater than 9? And is I greater than or equal to 0? It is. So now we're going to copy the 15 over to here. So now this is 15. We decrement I by 1, so I is 0. And now we're looking at this index here. Is I greater or equal to 0? It is. Is the key at index 0 greater than the current key? It is. So now we're going to copy the 10 over to the next index. So that's now 10. And then we're going to decrement I again. So I is now equal to minus 1. So at this point, we move down to here. And now we're going to insert the key at the found location. And just to confirm, we're at index 0. So the key at I plus 1, which is minus 1 plus 1, which is 0. The key at index 0 is equal to 9. So now we're going to add the 9 here. And that's basically how we add the key at 9 to the leaf node here. which is
Yep.
how we got this. Okay. Because it's just me and Shaquille, unfortunately we couldn't get the others because everyone's busy. Yeah. Just wanted to go through one of the additions, and yeah. Anything to add, Shaquille?
No, I think that's all pretty good.
All right. Awesome. So yeah. Thanks for your help, and that's
Yeah, of
our
course.
BTree insertion.
Yeah. All right.